In this exercise, A is a list containing three elements, 0, 1, and 2. B gets assigned A, then the element at index 2 in B gets assigned 100. We'll go through each of the statements in this worksheet to understand what's happening. The first statement evaluates the false. Why is that? Let's look at the values of A and B. A is a list containing 0, 1, and 100, and B contains the same values. So while B does contain the elements specified in the AND statement, A does not, which violates the first part of the AND statement, making the whole statement false. The second statement also evaluates to false. Here, neither A nor B contain the elements specified, which violates both parts of the AND statement, making the whole statement false. The third statement evaluates to true, since both A and B contain the elements specified in the original statement. The fourth statement, IDA equals IDB, also returns true. Let's remind ourselves of what the ID function does. The ID function takes an object as an argument and returns an integer that uniquely identifies the object, which is the object's memory address. So if we look at the values of IDA and IDB, the key thing to notice here is that they're the same. This means that both A and B point to the same object in memory. The statement B gets assigned A from the starter code makes B point to the same list object that A was assigned, the list containing 0, 1, and 2. Thus, any subsequent changes to B will also be reflected in A. There's something very subtle but very important that we need to understand here. To explore it further, let's make a quick change to the starter code. Get rid of the last line. And instead of assigning A to B, let's assign B a list containing the same elements as A. We'll run that. By doing this, A and B each point to two individual list objects in memory. And we can verify that by calling the ID function on both of the objects. And we notice that now both of these objects reside at different addresses in memory. So when we change an element in A, the change only happens in the list object that A is pointing to. In contrast, if we revert back to the original starter code, B will now point to the same list object that A points to. And we can verify that by calling the ID function on both A and B. And we notice that they now both point to the same list object in memory. So when we change an element in either A or B, let's make the second element in B 0, the change will happen in the same list object that both A and B are pointing to. This is called aliasing. More specifically, B is an alias for A, which means that we can change the same list object using either A or B as a name to refer to it.